Hey guys, so today for digital learning, we are going to learn about solving by intersection. So we're going to have two functions and we're going to see how to algebraically solve it to see where they're going to intersect and then actually how to graph it and see where they intersect. Okay, so first algebraically is pretty easy. You're just going to set the two things equal to each other. Okay, so this one we're just going to have x squared and 4. And so this one's a pretty easy equation to solve, right? And to solve for x, we just need to square root both sides. And just make sure when you square root something, you always put plus or minus, right? So we get x is plus or minus 2. And so that means at the x value 2 and negative 2, that is where it's going to intersect, okay? And so then to graph it and to see where it's actually going to intersect, we just graph the two lines. Okay, so I'm going to start with 4 because it's actually really easy. People just forget how to graph lines that are y equals 4. So this is a y equals 4 line. So really, you're going to go on the y-axis to 4. So that's here, and you're going to draw a horizontal line. It's kind of weird because a lot of people think y equals needs to be a vertical line, but it needs to go through the y-axis. So it's going to be a horizontal line. Okay, and then to graph this one, really the easiest way probably is just to make a little XY chart and plug in some values. And so since I already know it's going to cross at 2 and negative 2, I'll make sure to include those in my little chart I make. Okay, so I'm just going to plug in some values. I'll just do negative 2, negative 1, 0, 1, 2. And so if we plug those in, negative 2 squared, be careful guys, is a positive 4. Negative 1 squared is a positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So we got the points negative 2, 4. Negative 1, 1. 0, 0. 1, 1, and 2, 4. And so this is a parabola, right? A quadratic parabola, like that. Okay, and so you can see where they intersect. They cross at 2, 4, and negative 2, 4. Those are the 2 points where they intersect. So it says, what are the x-coordinates of so the x-coordinates are 2 and negative 2. And the next says, what are the solutions? The solutions are plus or minus 2. Right? So really when it asks for the solutions, it's really just asking for the x values. And so the x values that are the solutions are positive and negative 2. Okay? All right, let's keep going. Okay, so this next one, this time we have a line and a, like a linear line and a quadratic. So first, let's start off setting it equal to each other. And so you guys, whenever we have something like this that has an x squared and an x, we're going to have to factor it in order to solve it. And so in order to factor, we need to get everything to one side of the equation. So I'm going to subtract these two things over here. I know it's kind of weird that I didn't move the x squared, but I want the x squared to say positive. So you really want to move everything towards the positive x squared, not the other way around. Okay, so we have that. And so then from there, we just factor. So the two things that multiply to negative 3 and combine to negative 2 are negative 3 and positive 1. And then, so from that, remember when you actually solve that and you get the x values switch. So it's x equals 3 and x equals negative 1. So what are the x coordinates? I can already answer D, that the x coordinates of the points are negative 1 and 3, and the solutions are x equals 3 and x equals negative 1. But then I'm going to go ahead and actually graph these in order to see where they, what the y values are. But also, you can also just take these and plug them into the equations, right? Either equation, it doesn't matter. You plug it into the equation, that will be where it crosses. So once again, I need to graph this x squared. X squared, this time I need to go from 3. I need to go all the way to 3. So it's the same points as before. So negative 2, 4, 1, 2, 3, 4. Negative 1, 1, 0, 0, 1, 1, 2, 4. I'm just going to go one more, and I'm going to plug in a 3, and that would be 3, 9. 7, 8, 9. So that's up here, right? And I'll make the same point on the other side because it's symmetric, right? So we got this little x squared graph. That was really ugly, but, whatever. All right, and then we also need to graph this. So that is a linear line. So the way you graph linear lines, you always start at the y-intercept, so that 3 is the y-intercept, and then you look at the slope. So the slope here is 2 over 1, right? 2 over 1. Let me erase this because there we go. 2 over 1, which means you go up to right 1. Since everything's positive, you're going to go up and to the right. So up to right 1, up to right 1, up to right 1. So you can see that it crossed at that one little point. And then if we go the other way, we would go down to left 1. And so you could see if we did that, it would cross at that point there. Okay, so there we go. And so you can see the 2 points where they intersect is -1, 1 and 3, 9. Okay, which you could have also just figured out by plugging these into the equation, right? If we did -1 squared, we would have gotten 1, and 3 squared is 9. So you can kind of verify that way on the graph. Okay? All right, let's keep going. So this one this time is a little bit trickier. Let's solve it algebraically first. That's pretty much the same. The only thing that's going to be trickier this time is actually graphing it. So anyway, same thing. We got to get everything to one side. So I'm going to add the x over and subtract the 1. So that's x squared minus 6x plus 8 equals 0. And then that factors to x minus 4x minus 2. So we get the x values of 4 and 2. Okay? So those are going to be my x coordinates, 4 and 2, and those are my solutions, right? X equals 4, x equals 2. So I just need to plug it in. I'm actually going to plug it in this time since it's a little more complicated. I'm going to actually plug it into the easier equation because why would I plug it into the harder equation? So if I plug in a 4, that's -4 plus 1, that's -3. So that's going to be my first solution. And then my second solution, if I plug in a 2 here for x, that's 2 is my x value, and then -2 plus 1 is -1. So those are going to be the 2 points where they intersect. But we can also graph it in order to see that that is indeed where they intersect. Okay, so this time the linear line is going to be a little easier to graph, so let's go ahead and graph that. So I'm going to start at 1. Remember, you always start at this number here. That's the y-intercept. Okay, and then the number in front of x this time is a -1 over 1. So that means you're going to go down 1, right 1, down 1, right 1. Okay, so hopefully you guys remember that from algebra. And I know it's going to cross at 4, -3, so I'll just stop there because I know that's where it's going to cross. And at 2, -1, so I don't have to go the other direction at all. But if I wanted to, you would go the other way, up 1, left 1, right? Up 1, left 1. But I already know it's going to cross at 2, -1 and 4, -3. So all right, so that's the linear line. And then for the other line, I'm just going to go ahead once again and make a little chart. And I know I need to go all the way to 4 because I know that's where it's going to cross. So this time I'll do like -2, -1, 0, 1, 2, 3, 4. It's a lot of points, but you know, just to kind of get an idea. And you're just going to plug those in to x. So actually, I'm going to pause my video and I'm going to grab my calculator real quick. All right, so I grabbed my calculator, so let's start plugging in. And if you have a graphing calculator, there's easier ways to do this. Like you can just make a table and just copy down, you know, but you can always just plug in just like this. So I'm plugging in a -2 first, and that gives me 27. So that's way off the graph, so I'm not even going to worry about that. That's way off the graph, but you know, I already put it in the chart. So, and then I'm just going to copy and paste that, and then I'm going to just change the number to a -1 inside the parentheses so I don't have to retype everything. Okay, and then that's a 17, so that's still way off the graph. I know if I plug in a 0, I'm going to get a 9. Let's keep going. Let's plug in a 1 now. Okay, so let's retype that in, delete these negatives. Okay, 1 is a 3. Okay, so now we're getting to things that we can actually graph here. 2, let's see, let's plug in a 2 to the parentheses. Oops, go over 1. There we go. That's a -1. All right, and then I'm just going to go to 4 because I'm tired of plugging things in. And I know 4 is going to be a -3, right? But just to verify. God. Okay, something is wrong. Oh, I'm touching it with my pen, that's why. This is what happens when you try to digitally learn, guys. Actually, let me just do a 3 as well, because I already, you know. Okay, so 3 is -3, and then last, let's do 4, just to verify that we did it right. Dang it. Let me go fix that. And then that's a 4. Dang it, guys. There we go. There we go. So I got a -3 for both of those there. Okay. Anyway, so if we plot those 0, 9, that's where I'm going to start because obviously the other one is off the graph. So 0, 9 is here. 1, 3, 1, 2, 3. 2, -1. So that's my first point. It goes off of 3, -3. But then it's also 4, -3. So what's really happening here is that this goes and dips down and then comes back up. Something like that. So anyway, that one was a little harder to graph, but you know, you can just plug in all the points and just graph them. It's not that big of a deal. All right, and then the last one here, we have 2 quadratic equations. So the first one is actually the same as the one above, so I don't have to remake a chart for that one, so that's good. So you guys can like go ahead and just plot that one already. So what was it? 0, 9, 1, 3, 1, 1, 2, 3, 2, -1, 3, -1, 2, 3, 4, -3. Okay, so something like this, right? Okay, and then, all right, so let's solve this algebraically by setting these equal to each other so we can see where they're going to cross, so that when I graph it, I can, you know, make a little more sense of it. So this time we're going to move, what happens with this one's a little different because if I subtract over the x squared, what happens is that these are both going to cancel out. So I'm going to end up with -7x plus 9 equals -9x plus 15. And so for this one, you're actually only going to get one answer because you're not going to end up with an x squared. So anyway, let's add the 7x over. You could add the 9x. It doesn't matter which way you want to do it. That's -2x plus 15. You'll subtract over that 15. Hopefully we already know how to solve equations, right? So that's a -6 equals -2x, right? 9, 10, 11, 12, 13, 14, 15. Yeah. And then divide by -2. That gives you x equals 3. So that means this is going to cross at 3. And we already know from the other one that if we plugged in the 3, right, if we plug in a 3, we're going to get -3 as our y value because that's what we already did right here, right? So we know it's going to cross at 3, -3, this point right here, 3, -3. So let's go ahead and verify. I'll write that down here. Cross at 3, the x value is 3. We got x equals 3, right? That's really the main thing is x is 3 here. But anyway, let's go ahead and graph the other equation. And let me kind of show you the cheat way of doing that. So if you go to your calculator, so I kind of already did it here, but if you go to your calculator and you type this equation, the second equation, into y equals, and the x, you guys, when you're typing it in, is right here. Let me circle it. Is right here. That's the x button right there. So anyway, if you go ahead and you type this in and then you just hit second and then table, it brings up all these points for you. So you don't actually have to go through and plug in all these things. So anyway, then you just plot the different points and then you could just graph your curve. And you can see here that it does cross at 3, -3 right there. So you know, you can see that they do share that point, so that is where they're going to cross. I'm going to run out of time, so I don't have time to actually plot it, but you guys on your graph, go ahead and plot these different points, and then you can kind of draw the U, okay?